Aloha kako! Welcome to the Ne Papakahana online professional development for our mathematics activities. In this video, we will be going over the Let's Make the Kine curriculum that has been developed for grade 8 mathematics. The Let's Make the Kine curriculum is quite different from the usual curricula in our STEM D² book series. Instead of focusing on Common Core state standards or smarter balance assessments, Let's Make the Kine is a project book that allows students to collaborate and apply their mathematics to hands-on activities. If you're looking for our main curriculum or would like to explore our entire curricula series, please check out our website at stemd2.com. Some example projects in Let's Make the Kine include making a poi ball for traditional dances, making a simple toy fishing pole, combining two squares into a larger one using the Pythagorean theorem, and playing a battleship-style game using linear equations. Let's check out one of the activities together. In this video, we'll be going over activity 5.2 of Let's Make the Kine. This activity is called Pythagorean upena or net and will require a few supplies. First, the student will need some string or yarn. Then they'll need scissors and a ruler, and finally, they'll need a plastic pole or a smooth stick. They'll be working in groups and will only need one pole per group. In this activity, Ku'ule is making a net. She knows how tall she wants her net to be and how big each diamond-shaped hole should be. She doesn't want to waste any string or make the knots uneven. With a neighbor or a group, let's use our knowledge of triangles and irrational numbers to help her plan out her net design. Here's a diagram showing the net that we'll be making. At the top is a pole and a bunch of strings hanging from it. The center of the strings are tied to the pole, and the strings are also tied together with knots at regular intervals. The parts of the string that are between the knots are called bars, and the overall height of the completed net will be denoted by the variable h. Here are two diagrams of the diamond-shaped hole. Let's look at the distance from the top knot to the bottom knot of a hole so that we can estimate the overall height of the net. When the net is light and empty, the hole is wide open, and the distance from the top knot to the bottom is the diagonal d. When the net is heavy and full of fish, the top and bottom knots are pulled apart until the hole forms a slit. The height of this slit is called the eye length L. If the length of the bar is s, then the height of the net is somewhere between the square root of 2 times s and 2 times s. Feel free to pause the video if you want to think about why this is true. Welcome back. For the next part of the activity, we'll try to estimate the overall height of the net or the number of holes going up and down. We have that the height of a hole is between the square root of 2 times s and 2 times s, so if we have n rows of holes coming down the pole, then the overall height of the net will be between the square root of 2 times sn and 2 times sn. We can use this information to figure out how many rows of holes we need to make a net that is h in height. Please pause the video if you would like to check this out for yourself. In the final part of this activity, we'll be actually making the net. First, we have diagrams that show us how to tie the strings to the poles. Then we space the strings out evenly. And finally, we use the next diagrams to tie the knots for building the net. Over time, and with a lot of teamwork, the students will be able to make their own fishing net. Okay, and that's the basics of the kind of activities that this curriculum has to offer. Please check out our entire series of curricula at stemd2.com. On our website, you can also find the Olelo Hawaii version of this book, and it's called Ehana Ka Ko. Mahalo nui and a hui ho!